All right, welcome everybody. We're here back with another Infinite Layers with another team building on EigenLayer. Today I'm joined by Bo from Polymer. And Bo, do you mind giving us a quick introduction?
Yeah, absolutely. Yeah, thanks for having me, Nader. My name is Bo. I'm a technical co-founder at Polymer. We're building an interoperability hub on Ethereum called Polymer Hub. The goal there is to scalably and efficiently connect different layer twos to each other using IBC, as well as to the rest of the interchain.
Awesome. There is a lot to cover, and we're going to try to cover everything within about 35, 45 minutes here. So I think the first thing I would like to dive into a little further, even though you've already given us kind of a quick intro to Polymer, but if someone was to come to you and say, okay, what is the TLDR of Polymer? What is the elevator pitch, including, value proposition and other things that you might include, like what would that be?
Yeah, I would say that been long bullish on various Cosmos technologies. The very things that are most interesting to us are like the Cosmos SDK, IBC, and we've long been figuring out like what does the future look like. And I would say that we think that the future is going to be millions of rollups and millions of application-specific rollups. So we wanted to create an ecosystem of purpose-built rollups, starting with a purpose-built rollup for interoperability in the Polymer Hub, using a lot of these technologies, of course.
So, in terms of like some of the just more basic understanding of like the use cases, and I guess from the perspective of maybe someone that is already kind of very understanding of the modular space and all of the different, you know, rollups that are being built, would you say that this is something that would be for like larger rollups, like that are already existing out there today, like Optimism and Arbitrum to kind of interop? Or is this meant more for some of these newer rollups that are coming out to kind of add this functionality permissionlessly? Because like right now, we're
Yeah.
we're just seeing an explosion of different execution environments and also fragmentation.
Yeah, absolutely. So we are planning on supporting the long tail of rollups. We do support permissionless integrations of our protocol. We call that virtual IBC. It allows us or Polymer to take care of IBC execution on behalf of a connected rollup. And from I would say like high level perspective, we see that rollups are starting to form rollup clusters. And I gave a talk at Modular Summit on this idea of roll-up clusters being these like virtual local area networks, similar to how in the 70s and 80s you had this boon or growth in the number of custom local area networking protocols, as well as the birth of the internet. So I kind of see the interchain as the internet, IBC as TCP/IP, and Polymer Hub as a cross rollup cluster, or like I guess wide area network protocol over a lot of these existing clusters on Ethereum.
So in terms of the types of rollups that can use this, or the type of chains, you're kind of mixing the Cosmos, some ideas from Cosmos, into the Ethereum ecosystem. Is this meant for more like EVM compatible rollups, or is it meant for people building on the Cosmos SDK, or is it both?
It's both. So we will support EVM rollups. We will support other LVMs in the future, and we support Cosmos connecting to Cosmos SDK chains as they have IBC natively implemented as well.
Got it. So before we dive into kind of like why you chose this space to build in, because I want to kind of understand your story a little better, can we kind of like take a step back? I'm curious how you became a founder and how you got to like where you are, I guess, as an engineer.
Yeah, I have a background in database and distributed systems. I worked at Uber on the infrastructure team under observability, and I ended up leaving Uber to help start a company called Chronosphere. I worked there for a number of years. We were working on a B2B metrics and monitoring database, essentially this open source database called M3DB, uh, which was originally created at Uber for their workload, for their metrics workload. Uh, it was kind of an interesting story getting into crypto. I worked in crypto at one point a long time ago in like 2017, just on like various technologies out of like a technical interest. With DeFi Summer, I became curious about DeFi. Uh, the curiosity led me to work on a few DeFi protocols, although I'll say that wasn't my area of interest. I think I realized that a lot of these DeFi protocols do rely on some level of Ponzi-nomics and like these unsustainable token emissions. And ultimately, I wanted to work on infrastructure. I I, I saw the opportunity to work on interop as being able to hop in a time machine and go back to the 70s and 80s and get to work on the early internet. And that was like a very enticing proposition because I think,
Oh,
uh,
man.
yeah.
Very resonates with me a lot.
Oh, yeah, yeah, because like, it's like, I think at some point I'm gonna use Maslow's, like, hierarchy of needs here. I feel like I've been fortunate enough to, be able to, not have to worry about, like, daily necessities, having a job and being able to work in the US. Very thankful for a lot of things, like that. And at some point, you start like looking at like self-actualization, kind of like the top levels of the pyramid, and start wondering like, what can I do that will make me feel fulfilled and will make me feel like I'm contributing something. And that kind of like drove me to work in the space. That kind of is like a constant driver for me because I feel like I can't wake up every morning and get motivated by like money or like material things because like I'm not like
Yeah, you kind of like achieve that, right? I mean, when you get to the level of like Fang and working at these bigger companies, you've kind of reached essentially the peak of like engineering career. You could always go and become a founder like you've done, I guess. But in terms of actual, so yeah, it resonates a lot with me because I have a very similar story. It's like you start getting programming, you're excited, and then you start working your way up, and you achieve something,
Mhm.
and then at some point you're like, man, maybe a little bit bored. And then when you learn about the Web3 space, it did feel like, especially early on, and it still kind of does, you're kind of like rebuilding a lot of the earlier parts that you missed in the traditional space because it is still a lot earlier where we are. There's a lot of problems that need to be solved. So
Yeah, yeah, absolutely.
that's awesome. And then in terms of like approaching this problem specifically, like how did you all decide to build Polymer? Or why did y'all decide to build Polymer?
Yeah, so I'll give a shortened version of this. We initially were looking at building our own custom interoperability solution. Uh, was We were building with Cosmos SDK. I felt like that was the best framework to build a blockchain with at the time, and I think that's it's still a very competitive solution today. And as we're building, we started learning more about IBC. Realized that IBC has, or the IBC developers had solved a lot of these different edge cases and put a lot of thought into the core protocol, modeled it after TCP/IP, had a lot of nice properties and features that we wanted. So we switched over to focusing on IBC. And initially, we were focused on this world. At the time, we had this thesis of, okay, there's going to be millions of app chains. They're going to be layer ones. They're going to be these like Cosmos. There's going to be like millions of Cosmos layer ones in like some number of years. And over time, we started to realize that this wasn't the path the industry was taking. We still think there's going to be millions of app chains, but it appears now that there's going to be millions of app rollups versus layer ones. The properties of which of the two are very different. I think a lot of people talk about rollup being the new server. I think Sriram talks about this often, like rollup as a verifiable server. I think that analogy makes a lot of sense.
Got it. Yeah, I've been really exploring that whole analogy, trying to kind of build content that explains it in different ways, drawing a lot of analogies. I think from my experience in Web 2, I put out a video today actually diving further into that. But
Right.
in terms of, so I kind of want to talk about some of the challenges that I think a lot of teams building on EigenLayer are trying to solve, or they're offering various solutions for. One of them, well, they all often revolve around like scalability and UX, speed, things like that. But let's talk about scale and throughput specifically, and how maybe Polymer might offer some type of solution to kind of improve the current state of the art.
Yes. So the Polymer solution actually benefits from a lot of the work that the EigenLayer team is doing, like the EigenDA team is doing. By increasing DA bandwidth, Polymer is able to process more interop bandwidth through our systems. And if you think about interop from the perspective of safety, if you verify nothing, then your transaction payloads are going to be very small. if you start to verify anything, you start to realize that, oh, you have to include proofs. You have to prove this. You have to prove that. And if the proof sizes increases, then the amount of interop bandwidth needed also increases. And how cost efficient the propagation of that interop bandwidth is also increases as well. So EigenDA is a great product because we're able to push all that proof data through a DA layer that has higher throughput than what's available to us on Ethereum today, and which we're going to be bottlenecked by. So that's super important. Also, faster like DA confirmations is very important as well for interoperability. There's a lot of benefits from using Eigen products.
Yeah, that's super interesting. I think a lot of people think of EigenDA in terms of just traditional data availability for a rollup. But I think what you're talking about is kind of like using it for other reasons, which is something we're trying to also get more awareness around. So this is cool that you all are kind of doing that. I guess also in terms of security, is there anything that you would say that you feel like Polymer is helping to achieve there in terms of what already exists today?
Yeah, so there's, from our perspective, security is a spectrum. And the spectrum includes 5 different properties. Sriram has a great model for this. I think he talks about 2 properties for liveness, censorship resistance, and ledger growth, and 3 properties for safety, which is data availability, reorg resistance, and validity. And for the most part, interop protocols today really only deal with one of those properties. Most interop protocols only deal with validity. And maybe in a somewhat depressing fashion, many interop protocols are using very centralized solutions, even with that single property alone. Recently, there was a Twitter post by Sandman. It kind of went to show that a lot of the validity mechanisms for popular protocols today are anywhere between a 1 of 1 multisig to like a 3 of 5 multisig. So there's a lot of work that needs to be done there. But additionally, it's not just validity. There's reorg resistance or ordering. There's data availability. If you want to be able to prove these things, if you want to be able to verify these things, you need more interop bandwidth, which kind of leads us to the previous point of discussion on needing high interop bandwidth to be able to prove and to verify all of these things. So Polymer is attempting to take on each of these one at a time. So we're starting off with like a solid selection of validity mechanisms, ranging from different trade-offs between latency, between security, between how big the signer set is, between economic security. We'll offer a lot of different options there. And then additionally, we're going to tackle each of the other security properties as well. We're going to tackle ordering or reorg resistance. And we're working on the first and only reorg protected interop protocol. And we're also going to work on verifying data availability, which, with faster DA search from EigenDA, very helpful there. And we're also eventually going to work on liveness properties such as censorship resistance and so on.
Yeah, I think it makes a lot of sense. Like if you actually believe that we're going to kind of really start getting a ton of block space filled, so we're going to be scaling up individual networks, that means the interop is going to start scaling, and maybe it's going to need to start scaling, right? And maybe even need to start scaling more than the actual networks themselves, because if you're kind of thinking about, if you have hundreds or thousands of networks interacting with each other, how much bandwidth would be required for that? Do you think that what we'll see in terms of interoperability will be, like you mentioned, these clusters or these groups of networks maybe that will have more interop versus maybe separate ecosystems? And I think maybe a clear example of what that might look like is like you already have like this Optimism superchain, and you have Arbitrum orbits, and often you see people building within those silos. Do you think that we'll see, I guess, architectures that are more focused in that direction as opposed to having more like permissionless and open interop between anything? I'm just kind of trying to understand like what your own thoughts are in terms of where we're headed.
Yeah, I think most of these ecosystems are going to build a solution that works just for them. And this is very analogous to like early internet, like the Xeroxes of the world, the Apples of the world made protocols that worked for their devices, which makes a lot of sense. They wanted their devices to be networked. They wanted a solution right away. It's very quick to build something in-house. Um, I don't expect them to agree on a standard cross rollup ecosystem in the short term. My hunch is that on like the 10 to 20-year time frame, as the interchain grows, as the IBC network grows, and I'm making an analogy from like IBC to TCP/IP and the interchain to maybe like early ARPANET, and as ARPANET evolved into like the internet, that these I guess like local cluster specific protocol or roll up cluster specific protocols will kind of get absorbed, or they'll be like running side by side with IBC for some time, and then over time they'll just be like, okay, well let's just use IBC end to end. So I think there's going to be a transition period. It's not going to be fast. It's going to take a lot of time.
This is slightly off topic, but in terms of like IBC adoption, what is that currently looking like? I know like a year or two ago, oh no, it was like 2 years ago, 2.5 years ago when I was working with Celestia, it was starting to become more of like an exciting like idea, and people
Yeah.
were really bullish on it. And I think that people probably still are, but I haven't seen a ton of actual products that are kind of leveraging that I know of. But I'm also not that plugged into the Cosmos ecosystem.
Yeah, I mean, if you look at some concrete numbers here, I think the last time we checked, and this is not recent, so this is not up to date. I believe there are at least 4 to 5 blockchain frameworks that implement IBC natively. There's, I think, on the order of at least 20 teams that are core contributors to the IBC protocol. There's like at least like 5 to 10 different blockchain ecosystems that also have IBC. And there's a number of different interoperability protocols trying to build with IBC as well, which is very different from competing solutions, which it may only be a single company that's really backing it. So you have like multiple VC funded projects building with IBC. So I think there's a lot of momentum. I expect to see that momentum continue to grow over time, since it is like uh, arguably the most credibly neutral standard and protocol out of the ones that are live today.
Yeah, it kind of seems to be the gold standard and standard when people talk about interoperability.
Yeah.
So, okay, cool. So, I guess on to a slightly different question. We have now, there's been a lot of discussion on Twitter and stuff, especially. It's kind of like, do you build an L1 or do you build an L2? And like, what are the different trade offs? And people are very opinionated about this. But in terms of interoperability, does it really like matter all that much? And because if you can kind of have this network to network interoperability, do protocols like yourself even really care? Because and do you support different L1s as well as L2s and things like that?
Oh, we do. We do support connecting to different L1s as well as L2s, but there are UX differences. So if you have another layer one, and your layer one's consensus is not the same as Ethereum's consensus, you have 2 consensus layers. Going from Ethereum to that layer one, you have to wait for Ethereum finality, or you're taking on reorg risk. So is a trade-off between the two, which is not great, I would say. The UX has kind of a lower bound in terms of how good it can be. But then when you look at cross L2 interop, especially with the reorg protected solution that we're working on, you're able to go faster between these L2s without necessarily having to make this reorg risk to latency trade-off. And we're trying to allow developers to build applications that can communicate in practically real time, meaning that practically as fast as blocks are being produced across these rollups, with some reorg safety in place.
So, let's see here. I guess I want to take this in a different direction now and maybe talk about when someone wants to start building or building on or using Polymer from the perspective of a developer now. So, is this something that is permissionless? So if I'm launching like a rollup on Gelato or AltLayer or one of these rollups as a service, can I then go and pick up Polymer and say, okay, I now want to interact with Blast? Can I build that myself, or what does that process look like?
So it's tricky to do an integration on your own today, but we are planning on making the process more automated. Someone could technically do it, but having the know-how to do it is a completely different question. You have to deploy a set of smart contracts. You have to set up we call it like virtual IBC relayer. You have to set up like clients, I guess like connections, channels, all these like IBC specific things. And you have to do these things in the Cosmos. So if you have a new Cosmos chain, someone has to come along and like set up the relayer infrastructure, set up this, set up that. So it's not impossible for someone to do it, but we are trying to make it easier. So that someone will be able to just specify some information and ultimately have this process automated and integrated into various RAS providers where hopefully with just a click of a button, someone will be like, hey, I want to launch a new chain, or here's an existing chain and I want to connect it to the IBC network. Click the button and have all the work be automated for them.
Got it. So for right now, if someone wants to start integrating, they would probably approach your team
Yeah.
and you all would work together and get that going. Okay, cool. So I guess that you all have different companies and teams that you're already working with, and then if someone new comes on board, they go through some like input process.
Yeah, exactly. And we support a lot of different chains. The way our support works is we have a client template or an IBC client template for a specific type of chain. So depending on what the chain is, like we have a client template for OP Stack chains. It means if you're using OP Stack, you can use us. We have a client template for Lagrange State Committee chains. So if you're a chain, you have a Lagrange State Committee for your chain. You can permissionlessly join the network. So depending on what type of framework is being used, what type of client templates we have, they'll be able to kind of add themselves on their own. And you have this in the Cosmos where the most common IBC client template is the Tendermint like client template. And that means that any Comet BFT or Tendermint chain can connect to any other Tendermint chain because they all know how to verify each other.
Okay, so what would you say would be some of the main differences between what you all are trying to achieve versus the options that are already kind of like out there and existing? Like, where are
Yeah,
you trying to really improve and yeah, go from there?
Yeah, so from our perspective, there's multiple different high-level interoperability models at play today. There's the point-to-point model, and there's a number of protocols in that category. There's the hub and spoke model, and I'm going to call this a sovereign hub and spoke. And then there's a layer two hub and spoke model. So Polymer is in the third category, and I guess I'll explain why we felt like this architecture made sense. So you have teams today like Mega ETH are kind of pushing the boundaries of what's possible at the rollup level. 1 millisecond block times 100K TPS, maybe even a million TPS at some point. Imagine you put two Mega ETHs next to each other, and you try to fit in a sovereign hub and spoke protocol in the middle. That sovereign L1 hub and spoke protocol will not be able to keep up with the amount of throughput and the latency requirements because they have to pay for consensus. They have a kind of a lower ceiling in terms of scalability than these rollups because those are two, like L2 and L1 design space is inherently different. If you're a point-to-point protocol, you can support the throughput, but the cost effectiveness of adding certain features now becomes expensive. I'll just give you one example. So imagine this point-to-point protocol integrates Lagrange state committee. Okay, now you have n different chains and n different Lagrange state committees. You have to generate n different proofs and verify those proofs on n different chain. You have this n squared proof generation verification problem, and it's going to cost you. It's going to cost you 200, almost 200K gas per verification, maybe like 10 to 50 cents per proof generation. The cost of your system becomes very high. With Polymer as a hub and spoke protocol, as an L2, it means we can handle the scale. We can scale alongside these other L2s, kind of really push the boundary of what's possible there to kind of like the hardware level. And on top of the scale, we can also efficiently or cost effectively verify these proofs. So our Lagrange state committee integration only requires us to generate one proof and verify that on connected chains. So not n proofs, just one proof, no n squared verification problem or proof
Wow.
verification problem.
That's very, very clear and really underscores kind of, the value proposition because, kind of talking about it from maybe a lower level doesn't really go into that specifically, which is really cool.
Yeah.
So that's awesome. Which teams are you currently like working with and maybe that are public, and which teams would you say that are the types of maybe products that you would like to work with?
Yeah, so we're really excited about three different categories. These categories are not mutually exclusive. Some of them actually are broader categories that include the others. So we're very interested in chain abstraction, solver infrastructure, and intent-based liquidity bridges. That's kind of where the market is today. Uh, I mean, ideally, it'd be great if we're in a world where there's a lot of app chains and a lot of app rollups, and those app rollups are just, having are built in a way that doesn't require every like app chain or app rollup to bootstrap their own DeFi ecosystem. So there's a lot of kind of general cross-chain communication, but most of the cross-chain value today is liquidity transfer. So that's kind of the state of the world that we're in. We're working with Orb Labs on the chain abstraction front. For solver infrastructure, we're excited to collaborate with folks like Everclear. And for intent-based liquidity bridges, we're working with folks like Catalyst.
Would you say that there's a security trade-off at all between the architecture that you all have versus something that is like less scalable and is more expensive and is slower?
Yes. So there's a UX trade-off and there is a safety trade-off. So from a safety perspective, if you only have a one of three multisig or one of one multisig, that becomes somewhat insecure. And especially if this multisig is operated by someone who is not the sequencer of a rollup, there are designs where you can use a sequencer signature and trust that the rollup operator is being honest. This is very different from trusting a third party. So I would say that from a validity perspective, like we have options like Lagrange State Committee, where you can trust a larger set of nodes to attest to the validity of a chain, which is going to be more secure. We have our reorg protection protocol that allows us to communicate very fast across these different rollups. Like this fast communication can be combined with different validation mechanisms because ordering and validity are different properties. So we can have the ordering protocol combined with Lagrange State Committee or combined with a sequencer signature for validation. So you kind of mix and match and make trade-offs on what you want, like the level of security that you care about, the UX that you care about. If you want to go fast or you're okay waiting for Ethereum finality, it's up to the protocol. And there's like all sorts of trade-offs to be made, and we kind of try to make that very clear to the end developer.
Okay, awesome. I think that I've learned quite a bit, and I'm assuming that a lot of people watching have. Is there anything that we haven't really chatted about or covered that you wanted to point out or dive into before we wrap up and start diving into maybe some more learning resources for folks?
Yeah, I wanted to talk a little bit about the scale here that we're that we're dealing with. Uh, Back to my original point on if you want to prove certain things and to be more secure as a protocol, obviously if you prove nothing and the only thing you check is a single signature, your payload size is very small. But if you want to like have all these proofs, in fact, on our testnet with some of our proofing systems enabled, and we do have proofing systems that even work over the native bridge of a rollup. So we offer like the full spectrum of security. Like you want to wait a few hours, have very very high level of security, or you want to like go faster and have different security trade-offs. We support all those. Those proofing systems. I think at some points we're doing multiple megabytes per second of DA because of because of the sheer size of the proofs. So like this is kind of where interop bandwidth or secure interop bandwidth, there is a requirement on there being like abundant bandwidth there. So the fact that EigenDA is able to support like 10 megabytes and eventually 1 gigabytes per second of throughput is incredibly important to have secure interop bandwidth, because you're not going to have secure interop bandwidth unless you have proofs, and you're not going to have proofs with just verifying a single signature.
So I guess when you started actually diving into the more like technical design of all this, was a lot of it due to some of the opportunities that EigenLayer presented in terms of what was possible versus before that, or is this something you were going to try to achieve regardless of EigenLayer if it existed or not?
Yes, so it definitely helped us like be able to support certain levels of security, because if you don't have the interop bandwidth available to you, you can't do certain types of proofing, if that makes sense. So if let's say you can't connect like 10 chains with one proofing system at like X latency because the bandwidth requirement is going to be like 5 megabytes or 10 megabytes a second, and you only have like 768 kilobytes or like a few hundred kilobytes per second of bandwidth, then you have to design your systems in a completely different way. So you say like, okay, I'm going to cross off all these verification mechanisms, and then I'm going to go with this like one of like 2 or 3 multi-sig mechanism where like the proof sizes are a lot smaller.
Yeah, that makes sense. I'm also on that note, keep an eye on the EigenDA Twitter account. We're going to be announcing something really cool, some more improvements and enhancements there within the next day or two, I think. So,
Nice. That's
um,
awesome.
yeah, this has been really great. I learned a lot for sure, and I think that for anyone that maybe missed part of this, this is going to be up on YouTube. Just wanted to call that out, and also we're going to share a bunch of resources. But I guess this is a little different because it's not. It doesn't sound like it's just a developer platform that someone, like you said, at the moment can like go and permissionlessly deploy. But if someone is a developer, is like, what is the entry point for them right now to build or use Polymer in their app?
Yeah, we have docs at docs.polymerlabs.org where we've been on testnet for roughly half a year now. We're going on, and our testnet's always running. So anyone can go into our testnet, deploy applications, test their application. We are launching mainnet soon. I can't give an exact date, but I'll just say that it is happening soon. So yeah, be on the lookout for some big announcements in the coming months. And yeah, feel free to reach out to us follow us on Twitter, which is on the video above. Follow myself personally at 0xshake. And feel free to reach out to our team in Discord or any other social media mechanisms to chat.
Awesome. Well, this has been really great. Thank you for coming in and spending your time with us and explaining what Polymer is. For anyone watching, thanks for stopping by. We will be back next week with another Infinite Layers.